So first of all, let me just explain the title. STEAM, as most of you probably know, is the idea of mixing STEM subjects with the arts and humanities to make them more accessible. And interestingly, this year in May, the National Academy of Sciences put out a huge report basically seeing how well these efforts have actually changed the landscape of teaching and of research in this country. And it's a report called Trees of the Same Branches. So I'm going to be talking about some of these ideas. And the other thing is the word XY, it's actually XY, like sexy. So that's the pun I was trying to, never give up any kind of opportunity for a bad pun. So that's my motto. So let me tell you how I actually came upon this, how I became a STEAMy person. I was originally, for several years a mathematician ensconced in the world of math. And then, as our dean told you, something changed in my life. That's the sound effect. But what happened was I started writing novels, and one of them got published, and it did very well. And then I started writing more novels. And as a result, I actually started meeting a lot of people who were non-STEM people. I would go to these writing colonies and meet artists and writers and so on. And one of the interesting things was that they often didn't want to know what I was writing. They wanted to know something about math. They would say, give us a little math lecture, which was quite interesting. And so that made me sort of see whether math and fiction and math and narrative, what's the relation between them. And one of the lectures that I used to give was on infinity, because infinity is actually something that all of us have some sort of emotional attachment to. We all kind of have an idea of what infinity means. This actually got developed more at UMBC through a first-year seminar. And if you look at this leopard, you can see the infinity signs have been photoshopped in as the spots. And this was done by some students. We actually, one of the assignments for the class was to make some sort of outreach project that would engage non-mathematicians in math. And so they're the ones who introduced me to a little bit of animation and PowerPoint, and they came up with this. It's not coming up, I don't know why. Wait, let me try that again. Okay, now it's coming up. So this was a little tale that they came up with, and it actually was something that we put up on video, and there was a whole bunch of things that went along with that. So it was a fun thing, and it got quite a few hits, 25,000 last count, so that was good. Next project that I worked in was to teach a class with Professor Michelle Oshiro, who's in the English department. And what we did was we had a class that looked at the intersection of math and the humanities. This was a class that was designed, it was something called the Humanities Seminar. All the incoming scholarship holders in the humanities, about 13 of them, had to take this class. So boy, were they horrified when they saw that it's going to be about math. They thought they had done with math, so suddenly in their first semester they had to do this. And the class was very interesting. We came at this from very different angles, and Michelle and I were constantly kind of at loggerheads about how to present this material, our worldviews about it, so much so that we actually ended up writing a few articles about it. But then it turns out that Michelle is actually a theater person. She acts in plays and so on. So we decided that we would actually write a play about this. And we did a reading about it in a place in Canada, the university in Canada. Came back here, got Professor Alan Kreisenbeck from the theater department to direct us, and actually in this very room had two performances way back in, I think, 2014. It was sold out, both performances. And the nice thing is I got to act as well, because no one else would do the role. So, I got my thespian aspirations out of my system, so that was good. But then later on, it started actually, we performed it in many places, and then a couple of places like New Delhi and the University of Pittsburgh actually put on their own productions, and that was kind of neat. I like to now call it my international hit because New Delhi is on there. So that was an interesting kind of thing that happened. Professor LaCourse mentioned that I write these op-eds, so I was invited to write an op-ed, and one of the first one that I wrote on math was actually talking about how a lot of math people associate it with just calculation, but it's more than that. It's about ideas. And so the ideas can actually be enjoyed by everyone. You don't have to really calculate to understand some of the ideas behind it. And this was something that got very popular and was the most emailed for the day. There were about 360 comments, so that just showed how much people are interested in these kinds of issues. Not all the comments were positive. Most of them were, but there were also comments like, "I pity your students." I was just looking at them yesterday, and some of them were pretty bad. But the thing was the most emailed for the day, and it was actually going to be, you probably can't read this, but this was, it was actually moving up, and they keep track of what's the most emailed for the week. And I got up to number 2, and I was just about to make it to number 1. And then the Pope started making some sort of comments about gays and abortion and so on. And he just leapfrogged right into number 1 and denied me my position. So I'm still upset. I'm still upset with him a little bit. But so now the question that arises is, all the things I've talked about are sort of very informal. So they're about giving general populations ideas about math and doing math outreach. Can some of these ideas be actually used in a formal setting, in the STEAM setting in a classroom? And a few years ago, I went to St. Andrew's Elementary School, which is an inner city school in Toronto, very mixed, diverse, and mixed income. And one of the interesting things I saw was that in a 4th grade classroom, there was a teacher giving a lecture, giving a class to these students, and talking about using very simple narrative forms about Rapunzel, making her way to the door and not being able to do it because it took her a certain amount of time to travel half the distance, and then some more time to travel half the distance that was left. It's called Zeno's paradox. The students were enraptured, and they actually were able to access the concept of infinity through that. So this was quite amazing that these 4th graders were able to do that. And I think the key lies in, I think what this session is about stories, how they underlie so much of what we do, including math and the STEM subjects and so on. So was this something that I could work with? Well, I started writing something. One of the things that I feel is very different in math is, if you look at physics, it has an origin myth. If you look at many religions, they have origin myths too. So can you actually come up with an origin myth for math? And you can, as it turns out. The way mathematicians build up numbers is they start with nothing, the empty set, and then keep enclosing that in more sets, and essentially define the numbers as a succession of quantities. So using that kind of construction, you actually get all the numbers, and it's like a fuse, and suddenly you have this, what I like to call the Big Bang of numbers. So starting with that idea, I ended up with a kind of character who's making the numbers and actually builds all these numbers, and this character is called the Godfather of Numbers. So this was a book that I've been working on. I have it in draft form, and it's sort of like a bit of a mystery novel in there, a little element of that. But it actually goes through everything starting from numbers to arithmetic to algebra to geometry and physics and so on. And so what I've been doing is this semester I've been teaching 2 courses that actually use parts of this book. One is a first-year seminar that is entirely based on this, and the idea is to bring in video as well and see how some of these ideas, some of these STEAM ideas will work with classrooms. And the other is something that's a class called Math 120, and it's one of the classes that non-STEM majors take to fulfill their math requirement. And so we're using this and that as well. But now the thing to note is that either of these things, when you're looking at what the goals are of STEAM, it's not to completely replace the idea of a rigorous math instruction. It's actually to teach math as to be part of a bunch of things that are introduced to students. Thing with math is different people learn it in very different ways. And so you need a whole kind of palette of things that you can present. And so what we are doing is we are combining the STEAM parts with actual math parts and really trying to see how this can be brought together. So it's a little too soon to see how these experiments work. So maybe in a year I'll have more results. But thank you for your time. So that's my talk. Thank you.